3 at the beginning, which is 2, 3, and 5, okay? But of course, 7, 11, 13, 17, 19, 23, and so on, okay? So what is one thing you guys can tell me, what do you guys notice about all the prime numbers on this chart?
They, crap. The prime numbers are the highlighted ones or the non-highlighted ones?
The highlighted ones.
The highlighted ones, they can't be divided by another number. Or,
right.
They can
Well, that's one
only
thing.
oh, okay, cool. I got one.
they
Well,
can only be divided by one in itself.
Exactly. But just looking at this chart, just looking at it, what do you guys notice about it? What do you guys notice about the prime numbers?
Numbers, they're all odd.
They're all odd, yes. That's one thing for sure. Okay?
Okay.
There's actually only one even prime number, which is 2 up here. That's the only even prime number. The rest are odd. Okay? So that pretty much eliminates half of our numbers, right? But what else? What else do we notice? What about what they end with?
Oh, 7, 9, or 3, or 1.
Or 1, yeah. The most common ones are either going to end with a 1, a 3, a 7, or a 9, okay? So those are a couple things that we need to remember. And again, we're going to see why it becomes important, because what we're going to do is we're going to work with multiplying and dividing fractions, okay? But when we multiply and divide fractions, we want to make sure that we can reduce it as much as we possibly can, okay? So that's where our prime numbers and factors come in, okay? So let's just make sure we have something to write with. So let me go ahead and share the screen, okay? So when we're multiplying fractions, if you guys remember, what do we do to multiply these fractions? If you guys remember from last year.
The butterfly.
Actually, no, not with this case, right?
Don't you just multiply across?
Yeah, exactly. All you have to do is multiply straight across. Now, I'm actually, I'm glad you brought that up, okay? Because we only do that butterfly or whatever you want to call it when they're separated by an equal sign, okay?
Oh, okay.
That's the difference.
Yeah.
All right, but just so you guys are aware of that. But when you're multiplying, you just multiply straight across, okay? So 2 times 7, what is that?
14.
And then 3 times 11?
33.
So our answer? 14
over
33. Pretty easy, right? Now,
yeah.
we try to reduce if we can, but in this case, we actually can't, okay? So we're just gonna leave it as is. Okay? All right, let's go to our next example. 5 over 6, we're gonna multiply by 14 over 3. So again, all we have to do is multiply straight across. So 5 times 14. 5 times 14, that would be 70. And 6 times 3 is 18.
18. Dang it, I was just gonna hit them.
Okay?
Yes.
So now we can actually reduce this. The common factor is 2, so we can actually divide both of these by 2. So it would reduce to 35 over 9. And we'll talk a little bit more about reducing in a little bit, okay?
Yeah.
All right. Okay. Now, our next example, 2/7 times 5. Now, what are we going to do here to be able to multiply these two numbers together?
Put a 1 under 5.
Right. So remember from last week, we talked about how below every number, we assume that there is a 1. Okay, so now we just multiply straight across. 2 times 5, which gives us
10.
And then 7 times 1, which is
7.
7.
okay. Now the question, do you think we can reduce this?
You could reduce the top, but I don't know about the bottom.
Well, we can
No.
if we can't reduce both, then we can't reduce it at all, right?
Yeah, okay, then yeah,
So-
no. You can't.
Right. But we can reduce it, but there's a specific reason why.
Because it's improper.
No, even if it's improper, we can still reduce it. That's no problem there.
Okay.
But what were we just talking about earlier? What was the first thing that we talked about?
7 can't be reduced.
Well, it can be reduced, but like, why? What was the very first thing we talked about?
Because it's a prime number. Because it's a prime number.
So 7, that's a prime number. So because it's a prime number, we know that they can't share any factors, right? So automatically, we can say that we can reduce that, okay? So it's one thing that's pretty good to know about prime numbers is that as soon as we see one, we know that we can reduce the fraction, okay? So that's a pretty good like thing to know, okay? Let's do now 6 times 8 over 12. So again, to be able to multiply this, what do we do?
Put a 1 under 6.
Put a 1 under 6 and we multiply straight across.
6 times 8.
So 6 times 8, which is
6 times 8. 48.
it's 48.
Oh.
And then 12 times 1, which is
12.
12. Okay. Now, so what can we simplify this to?
Well, it goes in 48 4 times?
4, right? So
4 over 1.
4 over 1, which is the same, actually, you're right. So 4 over 1, which is the same thing as saying 4, right?
Yeah.
So
Yes.
in other words, remember what we said, what does a fraction imply that we're doing?
Dividing.
We're dividing, right? So 48 divided by 12, that's easy, that can easily reduce to a 4, right? 4 over 1, which is the same thing as saying 4. So 48 divided by 12 is 4, and we can simplify it to that. So if you notice, we took a fraction and we made it, and it turned into a whole number, okay? All right, pretty good. Okay, so now let's go into dividing fractions. And our key word that we should write down, the reciprocal. So can anybody remember what it means when I say reciprocal?
The
It's
opposite.
the fraction flipped from the, yeah, it's the opposite.
The opposite, okay?
Yeah.
So 2 over 3 divided by 4 over 11. So the way I say this is
Keep, change, flip.
right. I heard that one earlier. Keep, change, flip.
Yes.
Right. So yeah, we want to turn this into a multiplication problem because what we're doing right now is saying, okay, we're going to do 2 divided by 3 divided by 4 divided by 11. It's kind of crazy if you put it in those terms, right?
What the heck?
So 2, it's like 2 divided by 3 divided by 4 divided by 11. Like, it's pretty crazy, right? So we want to turn it into a multiplication problem. And to do that, it's the whole keep, change, flip. What we're going to do is that we're going to keep our 2 over 3, and then we change it into a multiplication problem, and then we're going to multiply by the reciprocal of 4 over 11. So what would be the reciprocal of 4 over 11?
11 over 4.
11 over 4. And now we have a multiplication problem. So let's do
So
split
11.
across.
20.
So we have 2 times 11 is 22
Over 4 or 12. My bad.
over 12. Okay? All right. Now let's work on actually trying to reduce this, okay? And just know I'm going to post some extra videos on reducing fractions, okay? So I'll give you guys a couple extra examples because it is kind of a hard thing to do, but I want to make sure that you guys are practicing that for your homework, okay? Because like technically this isn't a wrong answer, right? If it's not reduced, it's not a wrong answer. It's correct. But in most tests, the answer choice, if it's a multiple choice, the answer choice is going to be the simplest form. And that's why we do it, because we need to recognize what the fraction is the same as, right? So I'm going to list 22 and 11. Or sorry, 22 and 12. So first thing that I like to do is say, okay, 22 is an even number, right?
Yes.
So I can divide 22 by 2, right? And we're left over with what?
11.
11. Okay. Now 2 and 11, they're both prime numbers, right? So that's as far as we can go. So we just leave it like that. Okay. Now what about 12? That's also an even number. So let's divide 12 by 2.
That's 6.
6. Can we divide 6 again by 2?
Yes.
Yeah. So 2 and 3. All right. So again, 2 and 3, those are our prime numbers, so we're done. Okay. So now what is the common factor between the two of those numbers?
2.
2. Right? Those are our 2 matching numbers. Okay? So that means that we should divide both of these numbers by 2 to reduce the fraction. Okay? So what's 22 divided by 2?
11.
11.
Dang it. I should have known
And
that.
12 divided by 2 is
6.
6. So that's our reduced fraction. Okay?
So 11, 6.
11 over
11.
6. That's our simplest form. But here's what I want you guys to notice. Over here, on these numbers over here, what are we left with? Once we circle our 2, what are we left with?
11 and 6.
11 and 6.
Oh, dang.
See that?
Yeah.
So when we do it this way, we're actually not only finding our common factor, but we're also reducing it. We're reducing the fraction. Okay? So it's a pretty cool trick to see. Okay? And we'll continue practicing a little bit more, all right?
Okay. Yes.
Okay, but let's go to 3 over 7 divided by 3 over 7. So how would we set this up?
1?
How do we set this up?
Keep, change, flip.
So 3 over 7 times what? What's the reciprocal?
7/3.
7/3. Now we're going to multiply straight across,
3 times 7 is 21.
right? And on the bottom,
7 times 3 is 21.
21. And
20,
what
yeah,
can that
3
simplify
equals
to?
1.
21 divided by 1 is 1.
1.
So here's the thing, right? When we change 3/7 to 7/3, that's actually they're reciprocals of each other, right? 3/7 times 7/3. We're multiplying by the reciprocals. Whenever that happens, the answer is always going to be 1. Okay? We do this a lot when we are solving equations in algebra. So we're going to see a little bit more of this later on. But it's the same thing. Let's say if I was doing, I don't know, like, let's say we did 4/10, and I multiplied by 10/4. Those are reciprocals of each other, right? So that should also be equal to 1. Because 4 times 10, that's 40, and 10 times 4 is also 40. Okay? So whenever we're multiplying two reciprocals of each other, the answer is going to be 1. Again, this is just something to be aware of for when we get into algebra. Okay, almost done. Just got a couple more examples. All right. So 12/7 divided by 8. How would we set this one up?
Well, you keep change split.
Right, but remember the 8.
Right,
What
you're gonna
Put
put
the
a
8/1.
Right, we
8
have
over
8
1.
over 1. So again,
Then
change into multiplication. What is 8/1? What's the reciprocal of that?
1/8.
There we go, 1/8. So now we multiply straight across.
That's 12.
12/56. And this can actually reduce to 3/14. Okay. So again, I'm going to put some videos on examples of reducing fractions, just so you guys can see, okay? A couple more.
Okay.
All right, final one. 6 divided by 4/9.
Okay.
Put a 1.
So we're going to put the 1, right?
Yes.
We change it into a multiplication problem, and what are we going to multiply? What's the reciprocal?
9/4.
4.
Okay, I got it.
So 9/4. 6 times 9 is 54,
Yes.
and 4 times 1 is 4.
4.
This will reduce to, actually, let's go ahead and do this one. Okay, so remember that 54 and 4. So 4 is easy, right? We can divide that by 2,
Right.
and we're left with 2. That's it, right?
Yes.
Okay, 54, we can divide that by 2, and we're left with 27. So what's our common factor?
2.
2. So we can divide both of these by 2. So 54 divided by 4, or sorry, 54 divided by 2 is 27. And 4 divided by 2 is
Is 2.
2. Now, again, what are we left over with here?
Yeah.
See that? So that's an easier example, but as you can see, like it works pretty well, right? You see what you're left over with, and that's your reduced fraction. Okay. All right. Are you guys good with this?
Yes.
All right. So let's see. Let me make sure that we're good. Okay. So Your homework for today is it's going to be on Google Slides. Make sure that we are showing our work, okay, so we can get full credit. You guys did a pretty good job of that. So just make sure that you're showing your work and uploading your answers or your work onto the Google Slides. And again, try to practice reducing it to simplest form. Like I said, it's not the wrong answer if you leave it unreduced, but I want to see that you guys are trying to practice, okay? So I'm going to post a couple more examples on reducing the fraction so you guys can see those videos as well, all right? So it's going to be like 4 different examples. Hopefully it can help you guys out, okay? But in any case, just make sure to ask me in case you guys aren't sure, and I'll help you out, all right? But other than that, if you guys don't have any questions, that's it for today, okay?
Okay.
So I'll see you guys tomorrow at the same time.
Yes, sir.
All right, thank you guys. See you.
All right, bye.